I'm Ajit Khan, and in this tutorial we are going to learn about Logical Volume Manager. Before starting, let's spawn an instance which will be used for the practical session, the hands-on session. So I'm launching an instance with dynamic inventory using Ansible. So let's give it the name LVM. I'm using my personal account. So if you want to know about the dynamic inventory, I have a video tutorial about it. So go and watch it if you are interested to know how to spawn an instance using dynamic inventory. So let's spawn it. Okay, it's going on. So as for now, I don't have any instance. Meanwhile, let's jump to the LVM. So I have written a blog post regarding Logical Volume Manager. What is it and how to use it and its basic concept. So basically, Logical Volume Manager is a tool that can easily expand or combine multiple hard drives into a single storage, and it makes it easy to dynamically resize and increase the partitions. So uh, basically, say if you have a volume or a disk which is say 20 GB, and suppose your data is getting stored on it. Say for example, your MySQL DB is on volume 1, and it gets full and you need to add more disk or add more storage to it. Then you can use LVM, and then you can add further physical volumes or the second one more volume, say volume 2, and it would be added as an addition to the previous one. So data will get distributed to this volume 2 as well. So that could be a use case. So let's go ahead and see what are the components of LVM. So the first of all, we have physical volumes. So physical volumes are the volumes that are being attached to the instance and that can be used in a combined way to give the overall storage. So say for example, we have a volume which is slash dev slash sdb1, one more volume slash dev slash sdc1, and one more say slash dev slash sdc1. So as you can see here we have different physical volumes and a volume group, say sample VG. So we will be creating a volume group which will act as a combined volume over which we can have our logical volumes. So overall these physical volumes will be combined to make a single volume over which you can have your logical volumes being partitioned. Say for example, if you have say 20 GB each physical volume and your volume so you can have your logical volumes in a way that you can have a logical volume for storage for storing your songs, one more volume for storing your photos, and one more for save storing your MySQL data. So volume group are similar to actual disk drive with multiple partition, and logical volume made from the volume group similar to partition on the disk drive. So these diagrams will clear you more about it. So now we will see its installation and further steps. So let's see if we have our instance ready or not. So the script has done it works, and let's see if it has spawned or not. So we have our instance ready. Status check, it's still initializing. So and we have one root volume for it. The root volume we won't touch it. We will install and set up the LVM on one more volume. So let's create it. Say let's give it 10 gigs of storage. let's attach it to our instance. You can change it as per your requirements, say SDB, SDC, or whatever you want to. Okay, so we have our instance up and running. So we have SSH'd into that instance. Now we'll be installing LVM2. So I won't be using sudo, so I'll be the root user. Okay, so LVM is already installed on this Linux MI. So basically, but you can also install with the same command. So for now it's already been installed. So if we go ahead and see df minus s, so we have our root volume, and the newly created volume is not yet being attached, so we'll attach it later. And if you see this minus l, then here is our 10 gigs volume. So let's proceed now. First of all, we will be creating a new partition. So say we have slash dev xvdb1. So we have xvdb. So we can go ahead and run the fdisk slash dev slash xdb command. It will ask you for the prompt. Now let's see what all options are there. So you can press M for the help. So if you need to create a new partition, then press N to add a partition, and then you will use okay, so let's add a new partition. So the command is to enter here is N, and now it is asking partition type. So it is going to be a primary one, so let's give it P. Now it will have some default value like partition number per sector, blah blah blah, so you can leave it for the default. Now we will add the file system. So give input T. Now it's asking to type L if you want all the codes for it. So let's type L, and here we have all the list. So basically we will be making it as Linux LVM. So we'll be using the code 8E. So just give it 8E. Okay, and we are done for now. So simply to save this, give W and hit enter, and you are done. So the process has been stated here as well. So we have given the input W and save all our changes. Now we will create a physical volume. So the command is pv create. So it has been successfully created. The output looks similar to this. HDB1 has been created. And if we give the command pv display, the output should look similar to this. So we have pv size 10 gigs, pv name is this, and right now all our allocated and pv size are 0. Let's go ahead and create the volume group. So we'll be creating a volume group sample vg, although you can name it like anything. So sample vg is this. So we'll be creating the sample vg on slash dev sdb1. SDB1 here we are using because this PV creator has created it with the name SDB1. So let's go ahead. Sorry, VG create sample VG, and sample VG has been created successfully. To see volume groups, we can have VG display command, and here we have volume group name. This format is LVM2, and so on. Now we will create the logical volume. We can have multiple logical volume over a volume group. So here we will be creating it with the name sample LV, and we will be giving it 3 gigs space for now. So the command is lvm create hyphen hyphen name sample lv hyphen hyphen size 3 gig, and we are making it on sample vg. So let's go ahead. Logical volume sample lv created, and now we can see the output with lv display command, and the lv size we have given is 3 gigs, and lv name is sample lv, volume group is this, and the lv path is this. We'll be using this path for mounting the drive. Now we have created it, we can mount it. So we'll be using ext4 file format. So let's go ahead and format it first. So as I said, LV path is the one which you have to use. So it is formatted it. Now we can actually mount it and we can use it. So I'll be pointing it on /mnt. So let's go ahead and mount it. uh, as you can see, if you see, there is only root volume being mounted, yeah, till now. Sorry. So we have mounted it. Let's see if it has been mounted. So it has been mounted with /dev mapper sample, and as you can see, the size we have given is 2.9, 4.5 MB is used, and it is being mounted on /mnt. Now we have added our sample LV, and now we'll be extending our LVM to increase the partition size. So let's go ahead and add a physical volume. So let's name it first so that you can understand it well. Root. This is our first LVM, and let's create one more. Let's give it the size 20 gigs. Let's give it the name sample LVM. It has been created. Let's attach it. Previously we have added on SDB, so this time it should be SDC. So here we have XVDC, which is approximately 21 gigs. Now for this we have to repeat the steps from 1 to 5 and the PV create command. So let's go ahead and do this, and previously we were doing it for SDB. This time we have added it as SDC, so we'll be replacing it with SDC. So let's go ahead and do the same stuff. Disk /dev xvdc. Now it has asking for the command, and for the new one, and then P for the primary, and leave rest the things as default. Then The file system type, it is T, and the code is 8E, although you can list it by typing L. uh, so here we have 8E as Linux LVM, so let's give it 8E, and now write our changes. Now we can do pv create command. As you can see, previously it was SDB1, sorry, it was XVDB1, so it should be XVDC1. It has been created successfully. Now we will extend. So the command is, we are going to expand our sample VG. So the command is volume group extend VG extend sample VG, and the new partition. Now we are going to extend the LV. So it was being on /dev sample VG and sample LV. So let's go ahead and do this. So size of logical volume has been changed from 3 to 23, because previously we have given it only 3 gigs. We have given sample LV only 3 gigs, and later on we are extending the same with 20 gigs because we are adding a 20 GB volume to it. So the total become now 23. So it won't get directly reflected, so we need to resize it. So if you see df minus h, so still it's 3 gigs. So let's go ahead and resize it. See the difference, previously it was 3 gigs and the changes has been reflected. Now it's 23 gigs. So we have successfully extended our logical volumes, and previously it was 3 GB and it's now 20. Similarly, we can add some more disk volume on the same logical volume and increase the size accordingly. So that's all for this tutorial. Hope you like it. Any suggestion or feedback are most welcome in the comment box. Thanks for watching.